All right, today's topic in our unit Cells and Systems is topic 4, which is fluid movement in cells. So we will look at this topic in 2 lessons. The first part of the lesson we'll talk about fluid movement in cells, and then the second part we'll look at is fluid movement in plants. All right, so in cells, we're talking about the cell membrane here. So like we talked about when we were looking at organelles and cell structures, the cell membrane allows certain materials to pass in and out of the cell. So they're basically checked at the cell membrane. Think of it like a border of 2 nations. There's custom officers there checking items, travelers, and checking their luggage and so on. So the cell membrane will allow some substances to enter or leave the cell, and it stops other substances. And that's called selectively permeable. So that means allowing only certain materials to pass through. When we say something is permeable, that's a membrane that just allows all materials across. And if we say something is impermeable, it's a membrane that lets nothing across. All right, so the cell membrane is selectively permeable. Some things can go in and out, and some things are not able to go in and out. All right, so how do materials cross the selectively permeable membrane? So the first one method we're going to talk about is diffusion. So recall from the particle model in the previous unit, particles are always moving and bumping into each other. Particles that are concentrated in one area will spread apart into areas where there are fewer particles. That spreading out process is called diffusion. And eventually the particles will become evenly distributed. All right, so keep in mind, particles will always move from an area of high concentration to an area of low concentration until it's evenly distributed. So think about like spraying perfume in one corner of a room. Eventually, you'll be able to smell it across the room, and that's because of those particles. They're able to move from the area of high concentration, that's where you spray it, and they're able to move across the room, so the area of lower concentration, and that's going to keep doing that until they're evenly distributed. So in this example, in this beaker, we have put some ink into a beaker full of water, and we're not stirring, we're just letting it be. And eventually, because particles are always moving and they're going to move from high to low concentration, it'll keep moving until it's all evenly distributed. And then the whole solution will appear ink colored. All right, so diffusion in cells. Diffusion plays a part in moving substances in and out of cells. So here in this diagram, we have an equal concentration of carbon dioxide particles on both sides of the membrane. So this is the cell, this is its membrane. There's an equal amount of carbon dioxide on the outside as well as the inside. So the particles move into and out of the cell at an equal rate. Here, there's a greater concentration of carbon dioxide particles inside the cell. There's less on the outside of the cell. So the particles, therefore, are going to move out of the cell at a greater rate than they're moving into the cell. Right? So that's why we'll have more of that carbon, more particles are going to move out of the cell at a greater rate than they're moving into the cell until they reach equilibrium. And then we're going to talk about osmosis, and this is the movement of water. So it's the diffusion of specifically water through a selectively permeable membrane. Right? So the most common substance inside and outside of cells is water. About 70% of a cell's content is water. And water particles are small enough that they can easily move in and out of a cell, crossing the cell membrane by diffusion. So here In this diagram, we're just looking at limp carrot sticks that you sometimes might find in your fridge. So if you put them into a glass of water, about 2 hours later, they'll be back to being crisp carrot sticks again. And that's because of osmosis, the diffusion of water. So the water has now moved into the carrots to make them crispy again. Works with celery as well. All right, so continuing with osmosis, water moves from an area of high concentration to an area of low concentration. So that's why water moved into those limp dehydrated carrots. Now a question, what would happen if fresh carrots were put into a concentrated salt solution? So if we look at this diagram here, we have a membrane. It's a selectively permeable membrane. And the little blue circles represent the water particles, and the orange triangles represent the solute particles, so the salt. All right, so what we see, this is before osmosis, and then after osmosis, we can see the water level has decreased on side B. The water level has increased on side A because water moved to side A, okay, because water moves by osmosis from side B to side A inside that beaker, all right, because water is going to move towards the higher solute concentration. All right, so putting a carrot into salty water will make it shrivel up because as water leaves the carrot's cells to enter the salty water during the process of osmosis. All right, so we're going to stop here and watch a couple of these videos. The first one is on the naked egg and osmosis, and the second one is the amoeba sisters on osmosis.